This will be a question for all of you, which I'd like to keep short if we can. Your answer, we're going to try to get back to some more questions. In your opinion, what is the appropriate role of government in oil and gas research and development? Let me explain. Are we better off focusing limited federal funds on applied energy research or the demonstration and commercialization of energy technologies? Mr. Johnston?
So I would start by saying the leverage of the funds of the project that we have, I think, are a very appropriate way to utilize that fund. So we're actually taking first principles and marrying them with industry. So trying to get to the fundamental issue that's causing the inefficiencies in hydraulic fracturing, but also bringing partners along with that. I think that is a very appropriate role for these types of funds and these private public partnerships.
Okay, thank you, Mr. Brown.
I think one of the fundamental issues about research in general in the oil and gas industry starts really with the definition of what research and development really is. Because when I made the transition from aerospace into the oil world, research is defined much differently in both those environments. Research in aerospace oftentimes can start with a blank piece of paper and just thoughts as they start to generate. In oil and gas, research typically begins with something that's already somewhat downstream. I think if I were looking at where some of the funding could be utilized very effectively, it would be to have a hybrid of both of those two methods. Whereas you're thinking of new innovative methods that could solve some of the problems in oil and gas and combine that with things that are a little bit more mature.
All right, thank you. I appreciate it. Mr. Dimmig?
I think it's, in our experience, not an either-or scenario. I think we wouldn't have technologies to deploy if we don't have a robust R&D base, and we've benefited from R&D all throughout the Department of Energy, even R&D that wasn't intended for fossil fuels. So we have to start there. At the same time, I think we have to recognize that certain technologies that we think are very promising and the market thinks are very promising are very capital intensive, very difficult to get into the market with that first deployment. And so if we don't follow through with the most promising of those technologies, we might leave them behind.
Okay, I got you, Doctor.
I agree with my panelists. It's not an either-or. I think we learn some of our best lessons when we go to deploy them. When we go to deploy technologies, we come back and say, do we have to do a reset of our fundamental basic research that gets applied? And I think we've got to have a complete stream of this. But with the boom and bust cycles that are so common in the industry today, industry funding alone cannot move this industry forward.
Yeah, gotcha. And you're actually my next question. In your testimony, you discussed how oil and gas production is testing the limits of current understanding of engineering principles and presenting new problems along the way. For example, you wrote that, quote, as we access more high-temperature, high-pressure reservoirs with ultra-deepwater exploration and production, the material challenges have become more significant, end quote. You go on to write that your colleague is conducting materials research to develop new polymers to solve this challenge. Engineering is a practical field. Do you think these practical problems are actually leading to basic science research? And before you answer that, you said in your remarks earlier you wanted U of H to be the energy university. We want to make sure that happens. Do you think that these practical problems are leading to basic research?
Absolutely. In that basic research in materials design, in materials development, processing, and deployment is where these practical problems are leading to a significant change. And these are not going to just impact the oil and gas industry. It's going to have a much broader application, for instance, in the aerospace industry. We've had challenges in the deep water with the hydrogen-led embrittlement of bolts. This has got parallels to the aerospace industry, and what we've learned from either of those fields has led to really understanding and improving the technology in the field.
Yeah, good, thank you. Mr. Johnston, I'm going to jump back to you. Can you give us an update on the research at GTI's hydraulic fracturing test site What are some open problems that the scientists and engineers are trying to understand?
What they're really trying to figure out now is actually where the proppant goes through the, so we, in this project, we actually physically, chemically, and radioactively trace the proppant so that we have a better understanding of what happens within the transport mechanism. So today, it's really more of analyzing the production, inferring information about the physical evidence that we have, and validating and building new models that really help understand, you know, the process. Sometimes you induce as many questions as you answer with projects like this, and I think that's why, you know, continued research in this field is very important.
Well, that's true about a lot of research, isn't it?
It is.
Yeah.
It is.
All right, my time has expired. I'll now recognize Mr. Beesey.